Good morning, Wyzant students. My name is Gigi, and I'm going to help you with a stoichiometry problem today. Please keep in mind for videos, I talk fast because we're on a time crunch. Pause as you need. And I'm going to show you how to work through this step by step with basic, reusable strategies for any stoichiometry problem. So here our question was how many grams of H2O2, hydrogen peroxide, would have to react to produce 28.9 kilojoules of energy. I always ask students to identify the question first and any specific conditions, and luckily for us, this one is really straightforward. They're asking us for an amount of matter, how much stuff will we get when there is a certain amount of energy. I also like to point out, hey, is there any information we can ignore that doesn't matter? Well, yeah. In this problem, they're only asking you about hydrogen peroxide, the reactant, which means you can completely ignore both of the products in this reaction. And they're also not asking us about phase changes, so you can ignore whether it's in the liquid or gaseous state. So once we know what's not important, we then want to focus in on what is important. How can we simplify it? How can we even potentially translate it into something that's more easily understood? So if you compare what I crossed out above to this simplified reaction down below, I kept our hydrogen peroxide, our reactant, because that's the thing we're focusing on. Our coefficient is obviously still important, so we have 2 moles of hydrogen peroxide, and it produces 196 kilojoules of energy. You might be wondering, hey, where'd that negative sign go to? Well, the delta H value, or enthalpy, heat of reaction, anytime it has a negative sign, that's just telling you that the reaction is exothermic, as in heat is being produced. So if heat is being produced, we can just treat it as a product and therefore ignore the negative sign. So now you compare what you do know with what you need to find to work out your plan of attack. So putting our 2 statements side by side on the board, you'll see we have to go from moles to grams, and then we're going to have to adjust our amount of hydrogen peroxide for the specific energy condition that they gave us. So let's start with step 1, convert moles to grams. Our basic equation is right here. Moles times the gram formula mass gives you grams. You might have noticed, hey, we don't have the gram formula mass. How do I find it? Use your periodic table. Please don't go based off memory. Like this, your periodic table is an amazing resource. It's right there for you. Always use it. Always check it. So, gram formula mass. You're going to look up the atomic masses for each individual atom in your molecular formula. So for hydrogen peroxide, you look up hydrogen, which has an atomic mass, I'm just going to round to 1. And oxygen has its atomic mass of 16. So now we need to add all of those individual masses together. So remember, it's H2O2. So we have 2 hydrogens and 2 oxygens. So if we add all that together, we get 34 grams per mole for our gram formula mass. So now we're just going to plug and chug. We had into our original equation that I just gave you. So we had 2 moles of hydrogen peroxide. So that was from the reaction equation they gave us. You multiply by your gram formula mass that we just figured out. So now we know we have 68 grams of hydrogen peroxide producing 196 kilojoules of energy. So step 1 is done. Step 2, we now have to adjust our hydrogen peroxide for the smaller amount of energy. So quick reminder, this is an example of conservation of mass and energy. So if you have a certain amount of hydrogen peroxide producing a certain amount of energy, if you have a smaller amount of energy, that means you had to have a smaller amount of hydrogen peroxide. So if we compare these 2 statements and just turn them straight into an equation, like see if I took both of these arrows and turned them into an equal sign, and if I just put a line between the top and the bottom to act as that dividing bar, we've suddenly got this equation here. Rearrange it, plug it into your calculator, and you're going to solve for, you're going to have 10.02 da 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 da. Reminder, for Regents chemistry, you're going to have to use proper significant figures. Your shortest number only has 2 places, so your final answer should only have 2 places. Therefore, your final answer will be 10 grams of hydrogen peroxide. I hope this helps. Have a great day.